Okay, so would you make sure that you're on page 213 in your workbook so that we can talk about properties of logarithms. So there are a couple that aren't listed on here that I just want to make note of. The first is that if I have log base b of b, that just equals 1. And hopefully that makes sense to you, because again, remember that if we were to change this into exponential form, this would say b to the first equals b, right? Which hopefully makes a lot of sense to you. So if I'm taking log base b of the same thing, so log base 3 of 3 or log base 7 of 7. Oh, we have a visitor. Can you hop down? Sorry, it's a cat. That we end up with we just get 1. All right, this is interesting. Okay, so then the other one would be log base b of 1 is 0. Again, the reason is because b to the 0 would equal 1. All right, so log base b of b is 1, log base b of 1 is 0. And then the third one is log base b of b to the n. And that's just going to be n. All right, and again, the reason is if we change it into exponential form, that says b, that's the base, to the nth power equals b to the n. All right, so b to what power equals b to the n? It would have to be to the nth power. Oh my goodness, sorry. We have a visitor that does not want to leave. Okay, so those are some very basic properties of logs. But now let's talk about some other properties of logs called the product rule, the quotient rule, and the power rule. Again, I'm mentioning the change of base formula here, but we're not going to talk about it on this video. We're just going to talk about these three right here: product, quotient, and power. Right, so the product rule is telling us that if we have the log of a product, so m times n, or let's say x squared y, or whatever, if there is a product in there, then we can rewrite that as the sum of two individual logs, right? So that it would be log base b of m plus log base b of n, right? So I take this one logarithm, that's a log of a product, and I expand it, make it bigger, I guess you could think of it, but it's going to be the sum of the two individual logs, right? Then I have the quotient rule, which says that I have log base b of m over n. A quotient is the same thing as doing the difference of the individual logs, right? So again, if this were, I don't know, a squared over b, then that would be log base b of a squared over b is log base b of a squared minus log base b of b, right? So it would just separate them into two separate logs, and it would be the difference of them, right? And then the third rule is that log base b of m to the n, so if I have a power right here, hence the power rule, that it is the same as n times log base b of m. This third rule is essentially just a variation of the product rule, because if it was, let's say this had been squared, right? This would be m times m, and then I would just use the product rule, which would tell me that this was log base b of m plus log base b of m, which would just turn into 2 log base b of m, right? So, and then if I had a 3 here, because I had 3 m's, then this would just add another log base b of m, which would turn this into a 3 right here. So again, because we're multiplying the same thing together over and over again, it's a long sum just of all the same thing, and therefore that exponent becomes the coefficient. All right? In class, I'm hoping to prove at least the first one to you, but just for time's sake, we're not going to do that right now. Okay. Now, I have two things written here for you. If the directions say expand, then you're going to start with this. All right, so you're going to have a product, a quotient, or a power, and you're going to change it into a sum, a difference, or a coefficient right here. But again, equals sign is not one directional, it's both ways. So in other situations, we'll have a sum of 2 logs and we would like to condense it into 1 log, right? So instead of expanding it like this, we're trying to, and have multiple logs, we're trying to condense it and get it down to just 1 log. So sometimes we might see 2 logs with the same base that are added together, and we might want to write it as the product. Sometimes we might see 2 logs of the same base and we're taking the difference and we want to write it as 1 log of a quotient. Right? And sometimes we see a single log with a coefficient, and we want to rewrite it as a single log, but not with a coefficient. Instead, we want to write it with a power. Right? And so you'll see your directions will say expand, and then you'll know that you're supposed to think of it in this direction. You're supposed to look for products, quotients, and powers, and turn them into sums, differences, or coefficients. Or they might say simplify, or sometimes they'll say condense. And so then you'll know that you're supposed to look for a sum, a difference, or a power, or a coefficient, and turn it into a product, a quotient, or a power. Right, so again, you'll have to pay attention to what the directions say so that you know which side you should be looking for. Again, if it's expand, you're looking for this type of thing. And if it's condense or simplify, you're looking for something on this side. Right, so we'll do a couple of each just so that you get the hang of it. All right, so this first set says expand the following expressions. That means, again, here it says, when you expand, you want to leave no products, quotients, or exponents in your answer. So we're looking for products, quotients, and exponents to get rid of them. Also, I wrote a note here. Remember that if you're taking the nth root of something, again, that could be the square root, it could be the cube root, it could be the 4th root. We don't, we'll come across all of them. That root right there indicates a power. All right, so when you see that, you think, oh my gosh, we didn't talk about that in any of these. We did, it's just that we would rewrite it as a fractional exponent so that it would the power rule would apply. Okay, so let's take a look here. In problem number 1, we have log base 3 of 7 times t times w. So again, we're looking for products, we're looking for quotients, we're looking for exponents. So when I look at this, I see a product, I see no quotients, and I see no exponents. So I'm only going to apply the product rule here. And again, the product rule says that when I have a product of things, again, there were only 2 up here, but I could have it be many things and just separate it into many sums. We're going to break this into the sum of these things. So this would be log base 3 of 7 plus log base 3 of t plus log base 3 of w. And that would be the expanded version of this, right? And that would be our answer. Again, it's probably going to feel very unsatisfying. It's not an equation. We're not trying to solve for anything. We're just getting used to the idea that sometimes this format may be more helpful than this and vice versa. So we're getting used to the idea of switching between the 2 of them. All right, and the second one, I see no products, but I do see a quotient. All right, a divided by 3, and I don't see any exponents. So we're just going to use the quotient rule. Right, so this would say then log base 4 of a minus, because again, that's what the quotient rule says, that I subtract the 2 of them. Log base 4 of a minus log base 4 of 3 is equal to this. And that is our answer. Again, all they're asking us to do is expand, not solve, so we just stop when we've expanded. Okay, I look at this one. I'm looking for products, quotients, and exponents. I do see a product right here, and I do see a quotient right here. All right, because this product is part of the quotient, I would do the quotient first, and then we'll cycle around a second time and take care of that product. Right. So this would be log base b of 8f minus log base b of g. All right, so again, the product is part of that quotient, so we will just do that first, write it out using the quotient rule, and then let's cycle around again, and now say, all right, and here I've got log base b of 8 plus log base b of f minus log base b of g. And that would be your answer. Now, if you're saying, can I skip this step and just note that the top is going to become log base b of 8 plus log base b of f, and then just subtract that? The answer is yes. But if you would like to see all the steps, this is what you would do first. Just look at this as primarily a quotient with a product as part of it, and then separate that product afterwards. Okay, let's look at one that has an exponent. And again, it might not look right now like it's an exponent, but as I noted up here, this is the same thing as log base 3 of a to the 1/5. All right, and so we're going to say that this, now again, this rule says that I bring the exponent down to the front, so this becomes 1/5 log base 3 of a. All right, so then given our work on this one, what do you think this one should be? All right, hopefully you said it should be log base b of 2g to the 1/2 power. All right, so again, do you see any products? Do you see any quotients? Do you see any powers? So hopefully you would say no quotients. All right, it's pretty clear there's no fractions in here. I do see a product, and I do see an exponent. And again, this exponent is applying to both of these things in here. All right, so you could just say, all right, I see log of a power, and you're going to do the power first, all right, and then expand that. Or you might say, hey, I can distribute that 1/2, and I'll end up with two separate, I'll end up with a product that each have an exponent in it. Let's do it twice. Let's do it once each way just so you can see what it would look like. So I'm going to ignore what's in here and say this is primarily a power, right? In which case that 1/2 comes down the front, and then it's log base b of 2g. All right, now I still see a power. I still see a product in here, and this is where you need to be tricky. Specifically in this case, this is going to become 1/2. Now it's going to break into a sum, but realize it's still 1/2 of whatever this is. So if this turns from just a single log into 2, we have to make sure that we're doing half of both. So this is going to be log base b of 2 plus log base b of g. All right, so that's one way to do it. That is one answer. Now, if on the other hand you look at this and you say, I would rather distribute that exponent through first, so this is 2 to the 1/2 times g to the 1/2, you could also do that. It's still a product, all right, so we're going to go from here and say this is log base b of 2 to the 1/2, and again, product gets split into the sum of the two logs, so log base b of g to the 1/2. And now we'd say, wait a minute, I still have a power, so I'm going to use the power rule. This would become 1/2 log base b of 2 plus 1/2 log base b of g. So notice how our two different answers, the two different methods that we use, give answers that look slightly different from each other. However, if I distribute that 1/2 through, I do get exactly the same thing. Sorry, I'm just realizing maybe you couldn't see that bottom part. So the two different answers that we get are actually the same ones we distribute. All right, and again, it doesn't matter which one. My tendency is to do the 1/2 first. However, I feel like students make less mistakes if they distribute the exponent first because they often forget these parentheses around there. So if you're not going to forget the parentheses, then that's fine. Choose the power rule first. But if you are prone to forgetting parentheses, I would distribute the exponent first. That way you don't have to worry about parentheses. Okay, number 6. Actually, let's do number 7. Since we just did 2 with fractional exponents, let's take a look at number 7 on page 214. All right, again, we have that same situation here where we've got an exponent. So let's just do it where we distribute the exponent first so that we don't have to do both, like we don't have to worry about the parentheses. So this would become log base b of t to the 6th times v to the 4th times w squared. All right, again, we have a product here of three things, and so our product rule says that I can break this apart as a sum. So log base b of t to the 6th plus log base b of v to the 4th plus log base b of w to the 2nd. All right, and now we have that power on each of these that we have to bring down to the front. So 6 log base b of t plus 4 log base b of v plus 2 log base b of w. And again, I think that is totally fine. If you're worried about the fact that now there is a GCF, that's fine, you can pull it out. But again, it depends on what we're going to do with it, so I would say don't worry about that right now. All right, I'm going to let you try problem number 8 and 6 on the previous page just to challenge you. Again, they are a little bit harder, but hopefully you'll feel like you're ready to do them. Okay, so then again, we said back here that you could be given a single log and asked to expand it, or you could be given sums, differences, or multiple versions of the same log and be asked to condense it. I would say more often than not, that's what's going to happen, specifically when we are solving equations. We don't want multiple logs in it, we just want one, and so we want to condense it down to a single log. So from a practical standpoint, I think these are the ones that are going to be more useful to us, although I feel like for some reason people find expanding easier. I'm not sure why. Okay, so simplify the following expression. So again, note when you simplify, you want to make sure that there are no sums left, no differences left, or no coefficients left, because we're trying to condense to a single expression here. All right, so I look here and I would say, well, I see a sum, which I need to convert back into a product. Right, and so we would say, all right, well then this is going to become the single log, log base 2 of 9 times c. And again, probably in your answer you wouldn't write it with a dot, you would just say log base 2 of 9c. On some of our worksheets we'll see parentheses around them. I don't usually put parentheses around it unless the log has a difference in it for some reason. Not this has a difference in it, but this has a difference in it. If it's just multiplying or dividing, we don't usually write them, although it's not wrong to, but sometimes you'll see worksheets that do that anyway. Okay, number 10. Hold on for just a second. I want to make sure. Yeah. I'm just going to skip 13 and 15 and let you do this. Okay, so for number 10, we've got log base b of 8 plus log base b of m minus log base b of n. When you do it, I would say do it in terms of order of operations. So if you're looking at all these and you're saying, should I do addition or subtraction first? Remember, order of operations says when it's only addition and subtraction, just go left to right. And so we would just continue in this direction. Here we're going to go in this direction, so we'll do the addition first and then the subtraction second. All right, so I see addition, a sum, and I see a subtraction, but I see no coefficients. So we're just going to use the product rule and the quotient rule for these, because again, the sum comes from a product that was broken apart, so we're going to put it back together. A difference comes from a quotient that was broken apart, we're going to put it back together. All right, so we'll do these two first. So log base b of 8m minus log base b of n, and then that will become log base b of 8m over n. Final answer. All right, there's no simplifying that we could do here. Okay, again, same thing here. There is no difference and no coefficient. So we're just going to do a straight product. All right, so this is going to be log base 2 of 3t times 5t. All right, because again, I take the product of those, and we can simplify that even more. This would become log base 2 of 15t squared. Okay, so let's take a look at this one now with all these different terms, but again, we go through, we see a difference, so we know we're going to have to turn that into a quotient, another difference. We also notice here and here we have two coefficients, and so we're going to end up turning those into powers because of the power rule. All right, as we go through, we're going to do this order of operations, so we're just going to start with these two. Actually, no, you know what? Let's do this first, because this just simply applies to the t. This simply applies to the 3v. So we want to make sure that we put those in first so that we don't end up having them when we're getting ready to do our quotients there. All right, so when we put this up, we're going to end up with log base b of 2t minus log base b of 3v minus log base b of t squared plus log base b. Here's a place where you could easily make a mistake. This squared is going to apply to both of these things. So either write it as 3v squared, in parentheses there, or you could write it as 9v squared. That's the way I'm going to choose to write it. Again, you might like to leave it that way. I'm going to put it this way. Okay, so then let's go back and now just go left to right as we do this. And so let's take let's convert this into a quotient. Again, that comes from a difference right there. So we have log base b of 2t over 3v minus log base b of t squared plus log base b of 9v squared. Right, now, if you're freaking out, thinking right now that you're going to have to take this quotient and divide it by this, don't worry. Let's just think about when we divide a fraction by something. So if I have a over b divided by, well, let's say I start a over b, a over b divided by c. Again, we like to think of it as a over b divided by c this way, so that we see it as horizontal division, and then we just do keep, change, and flip. Again, this is a c over 1. So all we're going to end up doing when we do this subtraction is not do it as this over this, but we're going to just multiply this by the denominator. All right, so this is going to end up becoming log base b of 2t over 3v times this t squared, because again, keep, change, flip is going to bring that down to the bottom. All right, plus log base b of 9v squared. All right, now we have a sum of two things. This is going to convert into a product, and so let's write that as log base b of, again, now when we do a product, this is really over 1, so we're just multiplying the numerator, so this is going to become 18t v squared over 3, I'm going to write it as t squared v. All right, now you could leave it like that. You have condensed it, but we also could simplify this, so let's do that. That 18 divided by 3 is going to give us log base b of 6. This t and this t are going to cancel, so we end up with a t in the denominator, and one of these v's will cancel with that. So this is the most simplified version of this right here. Not too bad given what we started from. All right, so final answer, log base b of 6v divided by t. All right, I really want to look at this one with you because this also throws people off. This is saying, you could think of this as two different ways. One is order of operations says do the parentheses first, all right? And we are able to do that. It's a sum, and so we can turn it into a product. That would be one thing that we could do. And then once we get that product, we apply this exponent using the power rule to both of them. So let's do that way first, and then we'll talk about a second way we could do that. So this would be 3. We would condense this into log base b of 2t. And then we would just turn this into log base b of 2t cubed. Right, I use the power rule to bring that up. And again, this is the part where I'm concerned that you might make the mistake and just cube the t because it's right next to to the exponent. So make sure you put parentheses around them. Or you could write this as log base b of 8. Wow, that's a big B. Log base b of 8t cubed. Again, put that exponent, apply that exponent to both of them. All right, so that's method 1. Method 2 would be to say, hey, I'm afraid I'm going to forget to put parentheses around there and just write this as 2t cubed and get it wrong. So let me distribute that 3 through first. So it would be 3 log base b of 2 plus 3 log base b of t. And then we would do this part. So I would bring that up here and I would get log base b of 8 plus log base b of t cubed. When I do that, then I end up getting this log base b of 8t cubed. Again, it gets us to the same spot, but again, my concern is, just from past experience, a lot of people forget to put those parentheses around and they get the answer wrong because they put 2t cubed instead of doing 2t times 2t times 2t to get 8t cubed. If you're not going to make that mistake because you're really solid on your parentheses, then I would try this method instead, where you distribute first, then bring the exponent up onto each of them, and then combine. All right, let's look at number 16, and then we'll stop. All right, so again, I'm looking, I see a sum here that's going to become a product. I see a coefficient here that's going to become an exponent, another coefficient, and then a difference, which is going to become a quotient. Right, so again, I always recommend that you do the exponents first if they're not in they're not outside of parentheses like that. If that's the case, distribute first and then do it. But here, let's just put it up. So we've got log base 5 of 7 plus log base 5 of x to the 1/2 minus log base 5 of y squared. Again, if you don't like this, you can change it to square root of x right away. I'm just going to wait until the end to do that. All right, I have a sum that comes first, so this is going to be log base 5 of 7x to the 1/2 minus log base 5 of y squared. Then I'm going to do the difference, turn that back into a quotient, so log base 5 of 7x to the 1/2 over y squared. And then now at the end, I'm just going to write log base 5 of 7 square root of x. Again, it's only the x that has that 1/2 with it, not the 7. So don't try and apply it to that and accidentally put the 7 inside over y squared. Okay? Hopefully you feel all right with them. Bye.